In this short screencast, we'll be looking at sampling, in particular for doing a t-test. When we are doing comparison of two things, it's not enough to take just two values. We don't have enough measures of variability for the comparison. For a simple two-sample comparison, we need a sample of each treatment, or a number of plots for each treatment. We have to understand what our experimental unit is in the experiment. In this screencast, we'll talk a little bit about the statistical testing and in particular running a t-test in R code. So the steps for undertaking our experiment is to develop the research question, and when we're planning our experiment we think about the random sampling aspect. We have to plan our experiment, plan the treatments and consider collection of the data. Remember the three principles of experimental design: randomization, replication and reduction of experimental error. Why do we randomize? Remember, we want to avoid bias. It's a very important step and it must be undertaken. We need to randomize every time we repeat a particular experiment, even if we do it for 2 seasons. It's a separate randomization for each season. This requires practical knowledge of the context. So when you are a researcher, you need to first of all think of what your particular research question is. And for instance, on a research station, we might decide we want to compare 2 new varieties. We'll just call them variety A and variety B. So how can we set up this experiment? In this module, we explored the principles of experimental design by using replication, randomization. Let's divide the land into 10 plots and plot 5 random plots with variety A and the other 5 plots with variety B. Here's the random plots on the research station. I've just labelled them 1 to 10. They're all adjacent to each other and they're equal size. We need to randomise the treatment allocation to these 10 plots. I've labelled them 1 to 10. We need to assign the 2 varieties randomly so that each plot either gets an A or a B, and it's done randomly. So how do we do this? Well, I'm going to show you how to do this in R, but I'm just showing you here that, for instance, if we randomly assign our varieties B and varieties A to these 10 plots, it could quite easily come and look like this. On the left, you can see there are 10 plots. Those that are green, 5 green plots, will be planted with B. The other 5 plots will be planted with A. We have done this randomly, and we do follow the randomization. We don't change it. It's an important part of our experiment. So what I'm going to do here is very briefly, there's a lot of code here, but this is available for you to practice. Everything in green is in fact a comment. This is simple randomization using R. In our experiment, I've already mentioned we have variety A, variety B. We have 10 plots of land. It's completely randomized, and it'll actually be analysed as a 2-sample t-test. So the steps in this code, and let's look down to the black. First of all, we set our seed, and in this case I've got 7638. It doesn't matter what the seed is. Then here I'm just making a factor, so I'm saying F is a factor which consists of replicating 5 times each variety A and variety B. That just gives us in fact a list of 10 with equal variety A and variety B. Then we sample that. So when we sample it, this is where the randomization comes in, and then so we sample it 10 times, and then we will just have our experimental units 1 to 10, and we'll ask it to print out the data frame using our plot, our experimental unit, which is a plot, and our variety, which we've already assigned here. So don't worry about the detail, just understand how it works for your particular small experiment. We're then going to write a CSV file, and we're going to say I want the field plan to be written, and you can also have it written as a CSV file. So in this case, we will then print the randomization to the console and we'll be able to see it. So what we're doing when we look at the statistical question, we actually come up with a very simple comparison. We only have one hypothesis. And our null hypothesis in this situation is where there's no difference between our 2 varieties. And you can easily see that that could be the case. And the alternate, or the only other thing that could happen, is that there is a statistical difference, or in other words, that they are not equal. And we formally write this. Get used to this notation. We normally use symbols to define these 2 options. H0 is written formally as mu1 is equal to mu2, and this is our null hypothesis, NULL. and our mu1 is equal to mu2. These are just the population means for our variety A and variety B. And the alternate is written formally as this, not equal to. You can see this symbol here. And we just use, these hypotheses are written in terms of the population means, but we're actually taking a sample. So our statistical question would be, if we had a single sample, we might say, is the mean equal to a particular value? But in our case, we have got two samples. Are the two means the same? Is mu1, or the population mean for our variety A, equal to the population mean for a variety B? And the way we set up the test is dependent on a design. And in this case, we have two samples in a completely randomized design. So our two varieties are considered independent. And what statistics do we use? You can use a one-sample Z-test or T-test. In this case, ours is a two-sample T-statistic. And the critical values will depend either on the normal distribution if you're using a Z-test, or the T distribution if you're using a T-test. Since ours is sampling and we don't know the population means and the population standard deviations, we will be using the T distribution. Let's go back to some code. So what we're going to do here is we're going to actually just look through what we've done. So as I said, this is the first part where we're actually randomizing this is where the randomization is done, and we're using R code. All you need to do is write this small piece of code, and it'll be available on the site, on the BeST website. So what happens is here, this is what we got. And here you can see very briefly, this is our plot, then our variety, and this is what it looks like. So what we do at this stage, once you've used the previous code to give you this particular randomization, this is when you actually can put it onto your design, and then you can lay it out in the field. I showed this earlier on just to give you the idea of the fact that we need to randomize. And as you can see, I'll just go back to that previous slide, this is the way we can do the randomization in our R code. And this is what we get as our output. And then you yourself will transfer that onto the field plan. This is what I call the field plan over on the right. Then we run the trial. So this might be 2 or 3 months later, maybe 2 months later. And here you can see, this is showing you the summary of the yield as it appears in a CSV file, which you have learned before. So here I've got my plot, I've got my variety, and I've got my yields. And this is just the data. Okay, good. So what I'm going to do now is to use a second program where I analyze the data. These will both be available in the module. So the steps in this code say, let's read in the data from our CSV file with the plan and with the yields, because we need that plan. We need to know which plot, we need to know which treatment was assigned to which plot. So we're going to look at the data, remind ourselves of the variable names, and have a little look at what we've got. So what I'm doing here, plan Y, so this is basically yield, plan yield, and I'm saying assign this data, and I'm saying read CSV, which means I'm reading a CSV file, and here is the name of the CSV file, planyield.csv. And then I can say view plan, I can say head plan, names plan, length plan, histogram, plot. What you're doing here is you're just looking at the data. Head allows you to look at the top 5 lines or 6 lines of the data. Names just gives you the names of the variables in the data set. Length tells you how many in each variable. Histogram plots a histogram of the yield. Plot will also plot you a plot of the yield, in this case as a box plot. And you can do structure plan, which is always useful to just have a look at what your data set looks like, whether you've got anything that is actually a factor. Your variety should be factor. Then you can do a box plot, and the box plot by variety. So I'll just put that in there and explaining it. And then lastly, we can analyze a simple 2-sample t-test. And here the green is obviously the notes. So I'm just saying we'll undertake a t-test. Y is numeric and X is a binary factor. So what we're saying here, this is the format of the command in R, t-test, open brackets Y tilde X. The data's not structured, there's no blocks in this data. So for my particular data, I'm going to say t-test, because that's the function, and then instead of y, I'm putting my yield variable. So it's coming from this data set with the yield. Plan y $yield gives me the y variable. I've got the tilde there, which is what's up here. And then this one is the variety. So this is the x. And then you run the t-test and see what you conclude. So here's the answer, or examining the output. It gives you, so this is, as I said, this line here is the way you do a t-test. Very simple. There's no blocks in this. There's no, it's just a 2-sample t-test. And it gives you, this is the output that you'll get. It says the data is yield by variety. This is the calculated t value, the t statistic from your data. This is the degrees of freedom. This is the p-value. And the alternate hypothesis here is that the true difference in means is not equal to 0. And get a 95% confidence interval of the difference. And the sample estimate, so the mean in group A comes out as this, and the mean in group B comes out as this. And because your p-value here, it's sort of marginal. This p-value is just under 0.05, and so it's sort of marginal. It's showing that there is a difference, but we might not take that as a given. We might want to try this again next year and see what happens then. So what we've done here is we've designed a 2-sample small experiment using randomization and replication. We've run some code, we've written out the field plan, we've run the experiment, we've pretended 3 months has gone past, we've collected the data, we've looked at the data, checked and plotted it, and run an appropriate test, in this case a 2-sample t-test. So what I'd like you to do is, with the code, put this into R and run it through and see how you go.